All right, so we're going to walk you through some of the equations and types of questions that we've asked regarding point-slope form. So let's start with number one. It's always a good idea to label your points, right? First thing you got to do is find the slope. So finding the slope, we're just going to use change in y over change in x. So y minus x, y2 minus y1 on the top, and x2 minus x1 on the bottom, and that gets you a slope of 3. Next thing you want to do is always write out the equation you're using before you plug things in, right? So this is the base form of the equation. Y minus y1 equals m times x minus x1. Now I'm just going to take this point, plug the y in and the x in, right? Notice I keep this negative sign and this negative sign no matter what this value is, okay? So this simplifies negative minus a negative, simplifies to a positive, and we get, using the distributive property, 3 times x is 3x, and 3 times negative 1 is negative 3, okay? Last thing I need to do to get this into slope-intercept form is subtract 2 on both sides, and these cancel, and I'm left with, give me 1 second. Yep, I caught a mistake there. This shouldn't be 1, this should be negative 5, because negative 3 minus 2 is negative 5. So your answer is y equals 3x minus 5. All right, let's talk about when we're given the slope and a point. A lot of people got confused by this letter A. All this means is one point on the line. They've chosen the letter A to let you know that, hey, point A is 4, negative 4. There are many other points on this line, as we know, and we can label them anything else we want, right? So if you want to, you can just ignore that. You have a slope and a point. Use your form of the equation to plug things in. I plug my y in here, my x in here, and I simplify. I get a positive 4. Using the distributive property, I get negative 2x plus 8, because negative times a negative is a plus. Just bring the 4 over, and I have negative 2x plus 4 is my slope-intercept form. Now, when you're given 2 points, again, this is just point A, and this is just point B. We could have labeled them anything else. If you want to ignore them, you can. We have 2 points, negative 2, 1, negative 5, 3. And our slope is 3 minus 1 is 2. Negative 5 minus negative 2 is negative 3. Again, we're just using change in y. We're just using that formula, finding the change in y and the change in x. So again, I plug it in. I use distributive property here and here. I add 3 on both sides. This is over here. And that's your final slope-intercept form. Now, a lot of people got confused by number 10. It says, provide the equation of a vertical and horizontal line that goes to the following point in point-slope form. Okay? So we will talk more about this in class, but let's take this one at a time, right? We have the point here. Now, a horizontal line going through that point looks like that, right? And we can take the y value, plug it in here, and the x value, plug it in here. And we know our slope must be 0 because this is a flat line, right? As x increases, y increases by 0. A flat line will always have a slope of 0. So this is your point-slope form of the horizontal line. The point-slope form of the vertical line we have down here, right? We can plug in our y, We know our slope is undefined because that's always the slope of a vertical line. You cannot divide by 0. And we can plug in our x value. This doesn't make sense though, so we need to write an equation that does make sense, right? We know at any point along this line, here, 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 x will always be -3, so that's a good equation for us to leave. And that's it.